Greetings, the Astro30 here yet again, and welcome to part 7 and hopefully the final part, I'm thinking it's going to be, of this AEL480 amplifier build. Now, I've received a package in the mail today, which is some more parts to complete this amplifier. So I'll get the bag open. So this final part is going to be doing the input selector, which I haven't designed the PCB for yet, but that's the reason for these parts here, because once I open the bag, without putting too much pressure on the contents because I don't want to break anything, is they've given me their mid-year sale catalogue. Cool, I'll read that later. And here we go, that's all I ordered. 3 sets of RCA sockets. So these are 4-way, that's what they call them. It's basically 2-way because it's 2 channel left and right. There's 3 of them, so that's 6 inputs total. And I need these parts so I can actually measure the dimensions before making the PCB. And especially where these pegs are to clip them to the PCB for mechanical strength. They do actually give you a mechanical drawing in the catalogue and online, but it's confusing because they say the mounting face is right where the ends of these RCA sockets are, as in on the outside wall, which is wrong. The mounting face is back here where the black bit is. So yeah, I needed the part to measure it correctly, especially with pin spacings, etc. And these 2 pins are offset slightly, so I've got to be careful of that. Plus, I'll be looking at it from the bottom, so when it actually comes to the PCB, I've actually got to reverse those pins around with their difference in distance. Otherwise, it won't fit, unless I just use large holes, of course, in the PCB. I'll figure that out when I actually come to route the PCB, which will be over the weekend. And I've got 5 of these M412H relays. They're a 12 volt coil, and they handle 1 amp at 24 volt DC. And I've used these before. It's half an amp at 120 volt AC. So yeah, these ones don't have an internal back EMF diode like the ones that JCast sell do, because yeah, they're kind of annoying. If you get it the wrong polarity, they don't work. These I used in the 15 watt plus 15 watt amplifier project build, and I got 5 of them for the 5 required channels. And so I'm not going to take too much footage of, you know, designing the PCB. I mean, that's not very interesting. Someone might find it interesting, but yeah, they'll make the video way too long. I'm just going to do that in my own time. Export the Gerber, have the PCB manufactured and sent here, and then I'll pick the video up with assembling the input selector. And then going through drilling the back panel to accept these RCA sockets, etc. And wire it up and test it. So that'll be what I'll be doing. But before I get to doing that, I want to finish off the front panel. And what do I mean by that? Well, I've also received another package today from Ultronics. I really should have put both shipments in the same package. I would have saved $10 in shipping, but that's okay. This set of parts is to finish off the front panel, because you may remember from the last part it doesn't have any knobs yet. Well, that's what these are. So if I can get the packaging open, we'll have a look at what I've got. A second mid-year sale catalogue, which I do not need. And here we go here. I've got a, I believe that's 28mm knob with a grub screw fitting, and 4 16mm knobs, aluminium natural colour with grub screw fittings. So those are going to go onto the front panel. I might start with base knob. They probably stick out a little bit further than I wanted to, but I don't think that's a great big issue. So there's the base one. And there we have what looks like a pretty good two-tone arrangement going on. I mean, if it annoys me, I can always file the shafts down further. But for now, I'm going to leave it as it is. There's really a good sense of satisfaction once you put knobs on something. I don't know what that is, but it is. There's the treble, and I'll just do the balance, and we're pretty much complete there. These knobs cost me all of about $18.20, something like that. And I thought Ultronics had a minimum of $20 order, but no, they shipped it at only $18, so that's good. That goes an awful long way in before it actually tightens. Wow. Check it out. Now, it actually looks more like something. Isn't that awesome? I am very happy with how that turned out. That two-tone look really makes this thing pop. Yeah. Oh. Ooh. No, seriously, no, it is kind of an excitement. I mean, yeah, there is a fair gap there between the edge of the pot shafts and the knob back, but that's fine. So I might just stand here and stare at that for a while and then move on. No, alright, let's get the input selector board done so it can be manufactured and sent to you. And magically, a couple of weeks later, but only a few seconds for you, the PCBs for the input selector have arrived. So I'll just open the box to reveal the PCBs, which look absolutely gorgeous as usual. So that's what I've got. They should fit in the case just nicely. I need to check well, mainly the footprints here for the RCA sockets, because I probably spent, I don't know, a good hour and a half measuring and remeasuring just to make sure that everything would fit. I still could have messed it up. So what I need to do is find out what I've done with my knife and get a PCB out, and we'll have a closer look at that. So there is a closer look at the PCB on the underside. I was trying to make this a single-sided, but yeah, routing became a nightmare and I'd have to use a lot of link wires. You'll also notice there's a large M4.3 hole here and here. Well, they again, like the switchboard, is for cable tie points, just to keep things neat. So I will show a schematic to this in just a moment, but I just want to verify the components are going to fit. So I'll take one of my RCA sockets, and I'm hoping that this fits. I think it will fit. I just can't quite get things to line up with the holes properly. If I just slightly tweak these terminals. Oops, I didn't want to do that. Just to see if I can get them to fit in the holes. It looks like it will fit, it's just going to be tight. And trying to do this on camera is kind of annoying. So I've got one side to go in, so I reckon it will fit. It's just going to take a little bit of effort on trying to get the pins to bend in, because my measurements might be slightly off. But once you get it in there, it should be perfectly fine. Go on. Is it? Ah, you bastard. It actually fits in there beautifully. I've just got to be careful with these pins that they don't bend out of the way, because the first time I put it in there it did. But no, it fits in there, clips in there. The gap between the back of the PCB and the mounting point is pretty close. I can just slightly feel the lip there, so it's not that far off. So, and as we can see, the clips fit in their retainer holes just nicely. Oh, I'm so happy about that. That worked out just perfect. That's what happens when you actually measure the component 100 times before committing. And as KiCad is kind of really difficult for making footprints with and getting the measurements accurate, like to the millimeter, like the point of a millimeter, not without you know, changing your grid size constantly. But however, that looks fine. I mean, not all the pins are coming flush through the hole, but it should be fine. I mean, that should be perfectly functional. I just need an RCA plug just to make sure that they plug in, which they do. And it might be a good idea to just use an RCA plug and plug them in the sockets prior to soldering, just to make sure that all the pins are resting in properly. So I'm going to leave that in there now that it's in there. And even though it should fit, I'm going to check my relay. There's nothing worse than it doesn't fit. No, it fits perfectly. There we go. So those are the only two components I was concerned about fitting correctly. Everything else looks like it will fit correctly. Well, it should. So yeah, I can assemble this. And I won't take much footage of assembling it because there's no point. But I would start with all the lower profile components like the resistors, diodes, and then the larger components. Because I'm going to be using my jig to do it, I can leave that socket in there, it should be fine. So this is the complete schematic showing all the inputs, but I'll just focus in on the top one here. So at the top here we've got, for instance, the CD input. Now all the other inputs are the same, except there is no L-pad attenuation on the other connections. The only reason I'm using an L-pad attenuator here is to just bring the level of the CD player's output down so it's not as overdriving the rest of the inputs as it would be. We've got a set of relay contacts here. That's one relay, and then we've got another set of relay contacts here. Now this set of contacts is for the tape monitor relay. So what happens when it's selected to the tape on the rotary switch is this relay will then go and close between pins 3 and 6, which will connect the input from the tape in directly to the output, disconnecting the source. And when the tape is not selected and another input is selected, then these drop back out to normally closed, and whichever relay is turned on is then fed out to the output. The reason for that is so that the tape monitor is not feeding back the output of this selector back into the tape record output, back into the tape in. So if you have the tape recorder set to record mode, you'd get feedback. So this just isolates that circuit. So it's completely different from Rod Elliott's implementation. I just decided to go this way because I thought, well, it's simpler to just switch out the source inputs and switch in the tape into the output. And the tape out actually connects before this relay here, these relay contacts. So the output to the tape record comes from this point here and this point here and comes out. And this is a look at our drive circuitry. Here is the switchboard which is mounted to the front panel. It's a 6-position 2-pole switch set to 5 positions. We have plus 12 volts which comes off of this main board through this connector here. Coming into the center of the switch, it then, depending on which input is selected, comes out through its associated 47k resistor, through an LED, and out the relative pin on the jumper, on connector here. So say it was CT1, which is going to be the CD input. So that then, from the cathode of that LED, drives the base of this transistor and turns it on. The LED will turn on because there is a base to emitter junction, so there's going to be a current flow going that way through the LED. That's how the LED lights, as well as a current flow between the collector and emitter. That turns the relay on, which then closes the contacts of the relative input. And we've got a back EMF diode across the relay coil to stop any, back EMF from destroying the driver transistor. Over here is our plus 12 volt and ground input, which comes off of the regulator. And that's just going through this 10 microfarad filtering capacitor, which is just to bypass the supply lines on long supply lead runs from the actual power supply. It's probably not needed, but I've put it in there anyway. Looking at the output section after the tape monitor relay contacts, these ones here, we can see we're going through this second L-pad attenuator. Now, this allows me to tweak the gain of the preamp without having to modify resistors. So if there's too much gain at the preamp and the volume control is spending most of its time right down minimum to get a normal listening level, which is probably a little bit too fiddly, I can actually attenuate each input and drop the gain down before it reaches the power amp. It's only going to reduce it by about half, just to help that. And the test points here are for that particular purpose, so you can connect your oscilloscope probe and you can balance these channels so that you get an even amount of sine wave voltage coming out both the left and the right connection points. That is the whole entire point. I also apologise for me sniffing a bit. I have actually got a cold at the moment. So this may or may not make sense, but basically that's the reason for the second attenuator, which on the PCB lives down here. So you can then twiddle the multi-turn pots. I've used multi-turn because it's a lot easier to get a precise setting than it is using just a single turn. And there's our test points there plus a ground, so that's where the oscilloscope probes would connect, and you would inject a oscillator signal into one of the inputs. So that's how that works. So now all I have to do is build it and test it. As I say, I'm not going to take much footage of this because, well, there's really little point. It'll just make the video longer for no reason. I'll just come back once I've actually soldered all the components in. And about an hour or so later, I've got it assembled. The biggest fiddly part was actually getting these RCA sockets to go into the PCB, but I got them in there. So it's starting to look like something. It's actually now ready to test. So the first test that I'm going to do is a functionality test to make sure that the relays work and the lights turn on. So I'll connect it up to the amplifier, turn it on, and see what happens. Alright, the PCB is hooked into the amplifier, and I've already gone ahead like a week or so ago. I made the connectors, so it makes it just easy to do things now. Now I have no idea what input this is selected to at the moment, and I don't really care. Turn it on, the first one, and it appears the light lights up at least. I can hear a relay click, hear a relay click, hear a relay click, and hear a relay click, and we hear a relay click. I don't know if the camera picked it up, but I can hear that it's working. Alright, I might hook the oscilloscope up and inject a signal into, well, I'll start with each input individually and see what happens. But I'll start with the CD first. And on my CD input, it looks like I've got a relatively balanced left and right signal, so the two pots for the attenuator aren't too far out from each other, so I don't have to fiddle with that. It's actually saying peak to peak voltage. We're actually 240 millivolt total on both, so they're actually both aligned. So that's on the CD input. and well, obviously nothing's going to happen there except a bunch of random noise. So what I need to do is switch the input around. So I'll switch to the next input, which is the video. And let's see here, get in there. As we can see, the signal's a lot stronger. So the attenuator of the CD LPAD attenuator is doing its job. I don't know, it might be limiting a little bit too much, but remember, a CD player can put out over 2 volt RMS. So yeah, and your standard line signal is only around about 250, 300 millivolt RMS. So that's the video input. I'll now switch to the next one. And by the way, the blue trace is the left and the yellow trace is the right. This is the tuner input that I've selected. Looks like we've got the same. Switch to the next input, which is the auxiliary, as I have denoted it. About the same. And now I'll go to tape in. And we seem to have... alright. And it doesn't matter, there we go, got tape in. So there should be nothing coming out of the RCA sockets for tape out. I can verify that by just removing one lead and touching it across the output of the next. Apart from some noise on the probe, there is no signal there. So if I leave that connected there and I swap the input back to the auxiliary, the one next to it, we won't see anything yet, and there we go. That is the yellow trace, so that's before the LPAD attenuator at the output of the board. So that's what's coming out of the tape out. So whatever's going in, which is, according to this, about 1 volt, is what's going to come back out. So yeah, the input selector is working as it should. I'm quite happy about that. The only thing now I have to do is just calibrate these two potentiometers to give us the correct attenuation to suit the preamp here. But I can do that at a later time. I just wanted to see a functional test of this, and yeah, it's functioning as it should. I keep stepping on my nipple. I mean, never mind. There's something on the floor I keep stepping on. So if I put this to the same voltage and I touch the other connector on the tape out, we can see that they are relatively even within about 10 millivolts of each other, which is perfect. So I'm happy about that. That input selector is working as it should. So I think the next logical thing to do would be to drill the back panel. I'll just make sure to measure the RCA sockets correctly so I get the measurements as accurate as I can by hand. Because there's nothing worse than when you start drilling something and then you start to fit something like that PCB with RCA sockets on, and say the preamp here, where the holes start to go off as it goes down the line, and so one end is jammed up right against the hole and the other end's just like sitting somewhere in the center. That's what I want to try and avoid. So I don't have time to do that at the moment, but I'm probably going to leave that till next week. And I did change these op amps in here to an OPA low noise op amp. It didn't really make much difference. They're OPA 2134Ps. And I got them from Melbourne, and funnily enough, it took 2 weeks for the bloody things to get here. I don't know why, it was only coming from Melbourne. Anyhow, and it was $6 for the postage. So yeah, with this project I'm going to take my time finishing it off, because I don't really want to rush it. And as I said when I was looking at the PCBs, or the schematic, whichever one it was, that I was sniffing a bit because I got a cold. I don't, apart from soldering a PCB, I don't really want to do too much manual labour that involves me having to, have good cognitive ability. if you know what I mean. So I'll rest up over this weekend coming, and next week I'll start to drill the panel. So again, I still can't put this project off the desk away yet until I've done that. But that'll also involve labelling the panel as well, and yeah, with me constantly sniffing all the time and my nose running, etc. Even soldering that PCB was a challenge, and it was really starting to piss me off because it was a challenge to get these RCA sockets in there. Probably should have made the through hole part of it a little bigger, so they would have fit in there with a little bit of you know, difference in tolerance. But yeah. So anyway, we'll move on to doing the panel, and then I'll do the final attenuation adjustment till it suits how I want it. And yeah, then we can finish this project up. So before I do that, I will do a click pop test. That is switching between inputs. There is no noise coming out the speaker. Go to the input where the signal's coming in. And I've got 1 volt peak to peak going in, which is roughly what the line voltage would be anyway, and I think the attenuator is set to where it should be. And also I should be able to go straight into the tape out, like so, and we hear the signal. So yeah, the circuit appears to be functioning as it should. Alright, so I've got the back panel marked out as to where to drill the RCA sockets. I'm just hoping that my drill's got enough snot in it because I forgot to recharge it. However, I've measured it and I've checked it, and everything for the most part seems to line up. I mean, I can always massage the holes after I've drilled them to fit the sockets a little bit more snugly. It is only the back panel, so it doesn't really matter if it's neat. But anyway, I'm going to center punch these out, and then I'm going to drill the pilot holes. So that's all the pilot holes drilled, and then drilled out to 3.2. For the most part, this board looks like it will actually line up with the hole pattern that I've drilled. So now all I've got to do is size these outer holes, all 12 of them, to 10mm to accept the board. Well, accept the RCA sockets on the board. And that's pretty much it for that. So I'm going to probably do that downstairs because it's going to make quite a mess, and plus I want to clamp it in something. Well, of course you get through halfway drilling the bloody thing and the bloody drill dies. So I've got the battery out of the drill on charge for half an hour, and hopefully they'll have enough stock to finish that hole and drill the other 6. I'm not worried about deburring at this stage. I can wait until I've got another half-hour charge in it to, you know, deburr it and shit. So yeah, I've got to wait another 20 minutes or so, and then I can continue on. What a pain in the ass. Alright, well, half an hour of charge on the drill was just enough to complete the job. Got all the 10mm holes drilled, and I'll just test the circuit board for fitment. So it goes that way, and pretty much they line up perfectly. So what I'm going to do is I'm going to find the 3 screws that I'm going to use, and just make sure that when I screw the thing together, it pulls it in straight. Don't want to tighten them too much because I've got to pull them back out. I don't want to stress the RCA sockets. Yeah, they look alright. There may be a slight bit of crookedness in them, but yeah, I think it will serve its purpose, and once it's tightened down it should pull everything square anyway. Well, that's what I'm hoping, and it looks alright for what it is. So what I have to do is pull that board back out and then just do the panel labelling. So, but first what I want to do is I want to check clearance in the case between the board and the power amps. That might be a good idea, otherwise I've just wasted like an hour of time here. Okay, if I move that wiring out of the way. Oh yeah, there's plenty of clearance there. I've got all of about probably 8mm between the back of the selector board here and the edge of the power amp at the front. So, okay, cool. Right, so there's the panel there, all marked out as best as I can with 30-year-old Electroset. It's come very finicky, very brittle, unfortunately. But it marks what each of the things do, so that's the main thing. And it's sitting in front of a fan forced heater. It was air dried outside for 5 minutes, and I'm going to leave it in front of this heater for probably 10 minutes or so, just to make sure that the clear coat that I've put on it is nice and hard. It is touch dry within 15 minutes, so because of the current temperature at the moment, I thought, well, I'll just fan force it a bit. And when that's nice and dry and hard, that's what she said, I can then put the panel back onto the rack case and reattach all its peripherals. And the only thing then I need to do is then just calibrate the input trim, the attenuation I mean, just so I can set it so it's not too far down towards minimum on that volume control pot, because when these pots get closer to their minimum resistance, on dual gangs anyway, the resistance variation between the two gangs is quite pronounced, so one channel will attenuate more at minimum than the other, so you get an imbalance is what I'm saying. That's the whole entire point of that attenuator, is to just try and combat that issue. I mean, the thing should have plenty of gain enough to drive this amplifier into distortion anyway. So, right, so I'm just going to wait for that panel to dry and then I can get on with it. Check it out, the two are now one and the screws are tight for the final time. I put the IEC socket in first and connected the ground before screwing the power panel in, because it's a lot easier to get to the socket, well, with the panel off than it is with it in, although looking at it now I could have probably got to the screws just nicely. So now I need to reattach all the peripherals here and then I can hook it up. Nice. Alright, and a short time later all the peripherals are in. These RCA sockets are not quite square, they're going at slight angles here and there. However, it'll do the job. I probably should have filed the holes out a little more, but that's perfectly fine. Everything is nicely cable tied into everything, and the transformer is finally cable tied, which you can't see, and everything's routed through clips and clamps and stuff to the chassis. It's all neat. So now I can hook this back up and, well, test it for a start, see if it still works, and then calibrate the input. Alright, let's do it. Right, let's see how well I did. No unusual noises. I've got the volume on my laptop up full. I've got a tone generator going in the web browser. I'm on the correct input as far as I know. And, well, I'm going to leave the volume control where it is now. And the sub is also hooked up, so this will be a good sound test. Okay, that's not too bad. However, I might want to just drop the level down, so I'll disconnect my left input and just work on the right hand channel only. The reason for that is simple, because the right hand speaker is closest to the wall, it's going to sound the loudest, so I want to actually attenuate the input with just the right speaker going and the sub. So I find which one's the right, which is that one. I would have thought that that would be dropping. I can't hear it dropping, so what I need to do is I need to hook it up to the scope to have a look at it. Okay. I might be going the wrong way actually, that probably is why. I should be going clockwise, not counterclockwise. Actually, that appears to be getting louder. So I'll drop that right down. That is pretty much as far as it goes. That's full rotation. So, okay, the attenuator is probably not really useful. I mean, if it annoys me, I can always modify the gain of the preamp. It's not really a big deal. So what I'll do is I'll set this for 1.1 volt peak to peak. And call it that. About there. And now I can plug the left hand channel back in, which is going to be twice as loud now. Disconnect the right, and I'll swap around the test probes, and I'll drop this one down to 1.1 volt. Other way. About there. So both channels should be even. So I might change my tone so the sub's not doing anything. It's always going to sound louder on the right hand speaker than it is on the left because it's up against the wall. So I need to really measure both channels at the same time to see if they're the same. And with both channels going, they're kind of around the same, except the blue trace, which is my right hand channel, is a little bit more powerful than the left. So I might have to just fiddle with the attenuator a little bit. Until I get it roughly the same as each other. Which is about there, which is about as close as I'm going to get it. So that's fine. Now I'm going to kill that tone because it's bloody annoying. There we go. So I guess it'd be fitting to play a song through the amplifier before I put the top on. Actually, the volume of that's not too bad. Nice. Excellent. So that's proving to work fine, and I think my attenuator is, yeah, pretty good for where it is. Now, I guess it'd be a good idea to put the top on for the final time. And this has been quite a journey, and I'm very glad that you guys followed me along with it. Right, now to find some screws. And there we are, the screws are in for the first and final time. And with that, it's complete. I'm very pleased about that. So, that can find a new home over the other side of the room, and I can start using it now. So, yeah, it's finished. Alright, well, I thank you for watching this series of videos of me building this thing. It only took me probably about 3 months to complete it, so that's not too bad of a build time, I guess, on a fairly complicated project. That's not including the power amplifiers. They were built ages ago before that. Anyhow, so if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya. I'll see you in the next video. Thanks for watching.